Hello guys, welcome to Bugs in Code, and the problem that we are going to solve today is capacity to ship packages within D days. Okay, so but before that, if you're new here and a person who likes stuff related to coding, then you can subscribe the channel so that you never miss out an update. So let's get started. The problem statement says that uh, a conveyor belt has packages that must be shipped from one port to another within days. Okay, so here days is basically a variable. Now the ith package on the conveyor belt has a weight of weights I. Okay. Each day we load the ship with packages on the conveyor belt in the order given by weights. This is very important. We may not load more weight than the maximum weight capacity of the ship. Okay. Return the least weight capacity of the ship. That will result all the packages on the conveyor belt being shipped within days. Okay, so let me just explain the problem statement here. So here an example is given and I'm going to take the same example. So what I will have is I have 1 2 3 4 5 6 7 8 9 10, and I have some number of days given, so total days is 15. What we have is we have these packages placed on a conveyor belt. So this is basically a conveyor belt, and we have packages placed. Okay, so we have packages with like 1 2 3 4 like this. So what we need to do is, and it is basically rotating in this direction, and what we need is we need to put them in a ship. So we are going to have a ship like this, and we will put these packages in the ship, and this ship is going to move uh, in the water from, like, if this is port P1, then I have to move this ship from P1 to P2. That's what the problem says. Now this ship is going to have a maximum weight capacity. Let's take max. So I need to minimize that weight capacity in order and return the maximum answer. How? Let me just tell you. One way we can ship package, like let me just talk about the ways in which we can ship the packages. So what we can do is, it is actually we have day 5, so let me just write here 5. Now what we have is, one option that we have, we can ship 1 2 3 4 in one day. After that I'm going to ship 5 6 another day. After that I'm going to ship the rest, like 7 8 9 10 in another day. So the total number of days taken is 1 2 3. So in 3 days I can ship packages in this order. So what is the total weight occupied by these 4 packages? It is going to be 4 plus 3 plus 2 plus 1, so it is basically 10. After that, what is the weight occupied by this? So it is basically 10 unit, and after that it is 11 unit, and this is going to be 10 plus 9 19, 19 plus 8 27, and 34 unit. So I need the maximum capacity of this ship to be 4. So 34. So here 34 is the weight capacity that I need for my ship. The second way that I can do is, I can supply the packages like 1 2 3 4 5 in day 1. After that I'm going to supply only 5 in day 2. So it is for the day 2, and after that I'm going to supply only 6 in the day 3. After that I'm going to supply only 7 in the day 4, and after that I'm going to supply 8 9 10 in the 5th day. So I'm not taking more than 5 days. And talking about the weight occupied by this, so it is going to take 15 unit of weight, and it is, let me just change the color here. So it is going to take 15 unit of weight, and it is going to take only 5 unit of weight. It is going to take 6 unit of weight. It is going to take 7 unit of weight. And what about this? It is going to take 27 unit of weight. 10 plus 9 19 plus 8 27. Now what I can do is, let me just write one other way, which is going to have 1 2 3 4 5 for day 1, and 5 6 for day 2. After that I will have 6 and 7 for day 3 and only 8 actually 8 for day 4 and 9 and 10 for day 5. So what it is going to occupy, so this will take 15 unit, it will take 11 unit, it will take 13 unit. Okay, so actually I'm doing some mistake here. 7 and 8 for this day and 9 for this day and only 10 for this day. So that's how I'm going to do, and it is basically going to take 15 unit, and it is going to take 9 unit, and it is going to take 10 unit. Out of all these I need a maximum weight capacity of 15 unit in order to ship all the packages within 5 days. So 15 is going to be your solution. Obviously there are many more ways, but out of all those ways 15 is going to be the most optimum way. So that's why we are having 15 as our answer. So if I have 15 as the weight capacity, then I can supply all the packages within d days. Now I hope you got the clear understanding of the problem statement, and let me just move to the solution. So let me just start the solution, and I'm going to take the same example. The example says that we are given 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now what I can do is, let's take day is equal to days equal to 110. So I have 10 days to supply all the packages. So what I'm going to have is, the most optimal way is, first day ship this package only, and thus in the second day ship this package, in the third day ship this, fourth day, fifth day, sixth day, seventh day, eighth day, ninth day, and 10th day. So that's how we are going to ship the packages, and out of all these, whatever is our maximum, so maximum of array is going to be our answer. So here 10 is the maximum weight capacity that we need to have in our ship in order to ship these packages. Now we came to know that we can have minimum answer as, so our minimum answer that we can have is the maximum element of the array. Also, let me talk about one more case. So one more case can be like, let me draw the same array again, and 1 2 3 4 5 6 7 8 9 10. So if I am given days equal to 1, I have to ship all these packages in just one day. So in that case, what I'm going to do is, I'm going to fill my ship with all the packages. So I will have my answer as the sum of all the elements in the array, isn't it? So now what I can write is, my maximum solution, my maximum answer that I can have is the sum of array elements. Let me just do this. I'm going to tell why I am doing so. So what I got is, after doing after considering these two cases, I get that my minimum answer that I can have is, let's take, okay, so my minimum answer that I can have is the maximum element of array, and my maximum answer that I can have is the sum of array elements. This is for day equal to the size of array, and this one is the day equal to 1. This is minimum. After that, one thing that I want to tell you is, my answer to any problem is going to lie between minimum and the maximum. So my answer for any problem is will lie between minimum and maximum. It will be always greater than minimum. It will always be smaller than minimum. Why? Let me tell you. I have included this 10. So what I can do is, if I am given less number of if I am given less number of days, then I can, what I can do is I need to consider two elements at a time. So it may be, I may be forced to include 10 and 9 together, or 10, 9 and 8 together, so it will always be greater than 10. And the maximum number of element that I can include is all the elements. So if I include all the elements, then I will get the sum. So that's why I'm saying that my answer will always lie between minimum and maximum. So what I can do now, I'm going to give you the idea which will be the linear search. What I'm going to do is I'm going to start a loop. So, it is like considering all the values between a minimum and maximum. So I will start a loop from min to max, and in this loop I will check whether I can supply all the packages. I will check whether I can supply all the packages. So check here, if you can supply, you can supply all packages within d days, within d days, and maximum should be our current I. So let's take I variable here. So maximum weight not more than I. But the question is how I'm going to check this. So in order to check this, what I'm going to do is let me draw the array again. So 1 2 3 4 5 6 7 8 9 10. So what I will have is I have to check, like, let's take 15. I'm going to do it for 15 unit. So I will check whether I can supply all the packages within d days, where I cannot have more than 15 unit of it. So is it possible? So it is, what I'm going to do is I'm going to check it. So what I will do is I will start from here, and I will keep adding the elements. Like, I have added 1. After that, 1 is smaller than the 15 units, so I can move further and I will add 2. Now this sum is 3, and 3 is smaller than 15 unit. After that I will add 3. So this sum is still smaller than 15, and I'm going to add 4, and similarly I'm going to add 15. 5. Now it is 15. After that, when I come to this point, so I have considered all these points, and when I come to this point, so it is a breakpoint. How? When I add 6 to this, then the sum become 21. 21, and 21 is something which is greater than 15 needed. So at this point, what I'm going to do is I have a counter, and which is initially equal to 0, and I'm going to, which is initially equal to 1, and I'm going to make this counter as 2. Now when I make this counter 2, then I make my sum equal to 6. Now my sum will start from 6, and it is the first day shipment that we have. After that, I'm going to add this 7, come to this 7, and I'm going to add this 7, so it will become 13. And after that, when I add 8, so I came to know that it is something which is greater than 15. So what I'm going to do is I'm going to, it is also breakpoint, I'm going to increase it 3, and now I'm going to start from this point. So my sum will become 8. After that, I will add 8 plus 9, and at this point I came to know that 8 plus 9 is something which is greater than 15. So this is also going to be a breakpoint, and now my day will become 4. And after that, when I add 10 to this, so 10 plus 9, 19 is also greater than 15. So I will start a new day from here, and it's going to be 5. At the end, I have shipped all the packages within 5 days. So days taken, is something equal to 5, which is not greater than the maximum number of days which are allowed to us. So, and also our sum was not greater than the maximum sum allowed at any point. So for this it is possible, so I will return yes, it's possible, man. Okay, but what if I have any element which is greater than the current sum? Like, here I am given 15 unit as my current weight capacity, and what I'm going to have is I'm going to let's have this element to be 25. At this point, since 25 is always greater than 15 unit, even if I include 25 uh, individually, like I will not group this element with any other, so still I have weight which is greater than 15 units, so it is not possible for this array. So if I found any element like array of I greater than max weight capacity, so I'm going to return false. I'm going to return no. Also, if days taken is, if days taken is greater than the allowed days, still I'm going to return no. Or is there any condition? No, there is no any condition. So these are the conditions that we have to include. So now I hope you guys got the clear understanding of this solution, and let me just implement this. So this is for the linear search, and let me just implement this. So this is the problem of the LeetCode, and I'm going to have my minimum as the minimum in the array. So it is a minimum, and similarly I have to take the maximum as sum. So I will take the sum. So it is going to be a sum, and now I will start a loop from minimum to maximum. So my solution can even be equal to the maximum element, and that's how we are going to do. Now let me just uh, check whether if it is possible. So is possible, I'm going to ask a question from a function, and that function is going to tell me yes or no. So weights, and I will pass the maximum weight allowed, and I will pass the days which are allowed to me. So if it is possible, then I'm going to return I. Why I'm just returning at this point? Because this is the minimum possible. After that I will I'm actually increasing the value of I, so that's why. And let me just now return -1. If it is not possible, then I will return -1. Now let me code one function which is possible or not. So it is going to be a boolean function. It will return either yes or no. Now I will have an integer array weights, or and I will have a max weight capacity. After that I will have days. So what I'm going to have is, now I'm going to have a sum and a count days. So I will call it days taken. Now I'm going to traverse the whole array. In the array, what I'm going to do is, if my current element has a weight which is greater than the maximum weight allowed, then I'm going to return false. It is not possible. So this is our first condition that we wrote in the board. After that, I'm going to add the current weight in my sum. Now my weight becomes greater than sum. So if my sum is greater than the maximum weight allowed, then I have to do something. What I need to do is, at that point I need to increase my days taken. So I'm going to take one more days. So I'm going to take one more day, and in that day I'm going to ship a new sequence of the packages which will start from the current weights. So this is what I'm going to do, and I will check if my days taken become greater than the total number of days allowed. So at this point I will return false. In the last, what I will do is, I will increase one more day, because when I have reached the end, so this will be also counted as a day, and in the end I will return whether my days taken is smaller than equal to the maximum days or not. So if it is greater, then I will return false, else I will return true. So this is about the implementation, and let me just submit it. Let's see whether it works or not. Okay, so it is giving me wrong answer. Why it's giving me wrong answer? It is saying that it's even working for the 21 days. Why 21 days? Let me just see this. So what I have done is I have taken my sum and count as 0 and I am traversing the whole array. After that, if my weight become greater than the maximum weight, uh, then I will return false. Else I will add. Okay, so at this point I don't need to add. Instead, I need to have my sum as the current weight. Let me just check it now. Okay, so it's working for the example test case, and let me just submit it. So this solution may show the time limit exceed error because we are using a linear search here. Okay, so it's working, and okay, so it got submitted successfully and it is 5% faster. But this is about the linear search solution. What I'm going to do now is I'm going to tell you the intuition behind can we use a binary search here. So let me just write here. Let's see whether we can use a binary search or not. So binary search. Each time what we are doing is we are traveling from min to max. So we are going to, since we are traveling from minimum to maximum, so it is obviously going to be sorted. So it has a sorted order. There is no doubt that it has a sorted order. After that, one thing that I want to tell you is at any point, if I'm not able to, like, if I'm not able to ship all the packages for that particular weight, then it is sure that I will not be able to ship all the packages for the weight smaller as well. Like this particular weight at any point is denoting the maximum ship weight capacity. So it is denoting maximum uh, ship capacity. Okay, so now what we have is we have the maximum ship capacity, and if it not possible for this particular capacity, then I need to increase the capacity. So what I'm going to do is for these minimum and maximum I'm going to calculate the mid element, and I will check whether it is possible for mid. So if it is possible for mid, then I'm going to move in this direction. Why? Because if it is possible for this mid, then I will check is it possible for any element smaller than mid, because if it is possible for the any element which is smaller, then that element can be my answer, and mid is not obviously going to be my answer in that case. And if it is not possible, so if it is for the possible, move to left. So move to left, and if it is not possible, then move to right. Moving to right basically means we are increasing the maximum weight holding capacity of our ship. So now let me just implement this approach as well. I hope you guys got the intuition behind the binary search. Like we started from the linear search and then we came to know about how we can apply binary search here. Now in order to use binary search, I need to have a variable which is going to store my answer. So answer will be equal to -1 initially. Now we know how binary search actually works. So while my minimum is smaller than equal to maximum, what I'm going to do is I'm going to calculate my mid. So my equal to mid will be equal to min plus max minus min by 2. Let me write here min. After that, I'm going to check if it's possible. The function is possible is not going to change. The function will remain same, and where I will have weight, I will have then mid as my maximum weight, and I will have this. So if it is possible, then I'm going to store this in my answer. So my answer will be equal to mid, and I will move to left whether I have any answer which is smaller than the current answer, and else I need to increase the weight capacity. So I'm going to do my max my min equal to mid plus 1, and here I will do max equal to, so it will be max. So this is all about the binary search solution. Let me just return the value. Okay, so let me just submit the solution now. Let's see whether it's working or not. So okay, it's working for example test cases, and let me just submit the solution. I think it should work. Okay, so it is also working. So this is all about this problem. This is basically a problem which you should not miss if you are a person who are actually learning the searching part of an array. So this problem is going to give you an idea how search works, and such type of problems can be you can see in the interviews as well. Like there is a problem which is allocate minimum number of pages. So and there are various problems others like aggressive cows, if you have heard about. So these are the problems which are based on binary search and really gives you an idea how binary search works in real life problems. So this is all about this problem.